Dear students, please open your textbook before you start listening. Underline important lines and mark difficult words. Use earphone or headphone for full concentration. Happy listening and happy learning. Textbook for class 10th. Subject Science. Chapter 1. Chemical Reactions and Equations. Page number 1. Consider the following situation of daily life and think what happens when. Point 1. Milk is left at room temperature during summer. Point 2. An iron tawa or pan or nail is left exposed to humid atmosphere. Point 3. Grapes get fermented. Point 4. Food is cooked. Point 5. Food gets digested in our body. Point 6. We respire. In all the above situations, the nature and the identity of the initial substance have somewhat changed. We have already learned about physical and chemical changes of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually meant by a chemical reaction. How do we came to know that a chemical reaction has taken place? Let us perform some activities to find the answer to these questions. Now, activity 1.1 with figure 1.1. In figure 1.1, burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass. Now starting activity 1.1. Caution. This activity needs the teacher's assistance. It would be better if students wear suitable eyeglasses. Clean a magnesium ribbon about 3 to 4 cm long by rubbing it with sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or burner and collect the ash so formed in a watch glass as shown in figure 1.1. Burn the magnesium ribbon, keeping it away as far as possible from your eyes. What do you observe? Page 2. You must observe that magnesium ribbon burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. Now activity 1.2 with figure 1.2. In figure 1.2, formation of hydrogen gas by the action of dilute sulfuric acid on zinc. Now starting activity 1.2. Take lead nitrate solution in a test tube. Add potassium iodide solution to this. What do you observe from the now activity 1.3. Take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid to this, as shown in figure 1.2. Question. Handle the acid with care. Do you observe anything happening around the zinc granules? Touch the conical flask or test tube. Is there any change in its temperature? From the above three activities, we can say that any of the following observations help us to determine whether a chemical reaction has taken place. Number 1. change in state. Number 2, change in color. Number 3, evolution of a gas. Number 4, change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and their symbolic representations in this chapter. 1.1 Chemical Equations. Activity 1.1 can be described as when a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation for the above reaction would be magnesium plus oxygen is reactant is equal to magnesium oxide, that is product. The substance that undergo chemical change in the reaction 1.1. Magnesium and oxygen are the reactants. The new substance is magnesium oxide formed during the reaction as a product. A word equation shows change of reactant to product through an arrow placed between them. The reactants are written on the left hand side LHS with a plus sign between them. Similarly, products are written on the right hand side RHS with a plus sign between them. The arrowhead points towards the product and shows the direction of the reaction. 1.1.1 Writing a chemical equation. Is there any other shorter way for representing chemical equations? Chemical equations can be made more concise and useful if we use chemical formulae instead of words. A chemical equation represents a chemical reaction. If you recall formulae of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 is equal to MgO. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on both the sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. 1.1.2 Balanced chemical equations. Recall the law of conservation of mass that you studied in class 9th. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the element present in the products of a chemical reaction has to be equal to the total mass of the element present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Is the chemical equation 1.2 balanced? Let us learn about balancing a chemical equation step by step. The word equation for activity 1.3 may be represented as zinc plus sulfuric acid is equal to zinc sulfate plus hydrogen. The above word equation may be represented by the following chemical equation. Zn plus H2SO4 is equal to ZnSO4 plus H2. Let us examine the number of atoms of different elements on both sides of the arrow by the below table. In one column, elements, second column, number of atoms in reactants, third column, number of atoms in products. For the element zinc, number of atom in reactant is 1, number of atom in product is 1. For hydrogen, number of atom in reactant 2, number of atom in product 2. Element 3, sulfur, number of atom in reactant 1, number of atom in product 1. For oxygen, number of atom in reactant 4, number of atom in product 4. As the number of atom of each element is the same on both sides of the arrow. 1.3 is a balanced chemical equation. Let us try to balance the following chemical equation. Fe plus H2O is equal to Fe3O4 plus H2. Step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Fe plus H2O is equal to Fe3O4 plus H2. 1.5. Step 2. List the number of atoms of different element present in the unbalanced equation by below table. This table are of 3 columns. Elements, number of atom in reactants, number of atom in products. For ferrous, number of atom in reactant 1, number of atom in product 3. Hydrogen, number of atom in reactant 2, number of atom in product 2. Oxygen, number of atom in reactant 1, number of atom in product 4. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS. To balance the oxygen atoms. Atoms of oxygen. Initial first in H2O, 4 in Fe3O4. Second, to balance 1 into 4 in product 4. To equalize the number of atoms, it must be remembered that we cannot alter the formulae of the compound or elements involved in the reactions. For example, to balance oxygen atom, we can put coefficient 4 as 4H2O and not H2O4 or H2O4. Now the partly balanced equation becomes Fe plus 4H2O is equal to Fe3O4 plus H2. Step 4. Fe and H atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atom in the partly balanced equation. To equalize the number of hydrogen atom, make the number of molecules of hydrogen as 4 on the RHS. By below table, atoms of hydrogen in reactant and in product. For initial, 8 in 4H2O, in product twice in H2. Second, to balance, in reactant 8, in product 2 into 4. The equation would be Fe plus 4H2O is equal to Fe3O4 plus 4H2. Step 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. Atom of iron in reactant in product. In first column initial, in second column 1 in Fe, in third column 3 in Fe3O4. In second line, to balance. In reactant 1:3, in product 3. To equalize Fe, we take 3 atoms of Fe on the LHS. Thrice Fe plus 4H2O is equal to Fe3O4 plus 4H2. Step 6. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. Thrice Fe plus 4H2O is equal to Fe3O4 plus 4H2. It is balanced equation. The number of atoms of element on both sides of equation 1.9 are equal. This equation is now balanced. This method of balancing chemical equation is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbols of physical states. Carefully examine the above balanced equation 1.9. Does this equation tell us anything about the physical state of each reactant and product? No information has been given in this equation about their physical states. To make a chemical equation more informative, the physical states of the reactant and product are mentioned along with their chemical formulae. The gaseous, liquid, aqueous, and solid states of reactants and products are represented by the notation gram, liter, AQ and S respectively. The word aqueous AQ is written if the reactant or product is present as a solution in water. The balanced equation 1.9 becomes thrice Fe plus 4H2O gas is equal to Fe3O4 S plus 4H2 gas. 1.10. Note that the symbol G is used with H2O to indicate that in this reaction water is used in the form of steam. Usually, physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, COG plus twice H2 is equal to on arrow 340 atm is equal to CH3OH 1.11. 6CO2 AQ plus twice H2O L on arrow sunlight and chlorophyll is equal to C6H12O6 AQ plus 6O2 AQ plus 6H2O L. Equation 1.12. Using these steps, can you balance equation 1.2 given in the text earlier? Now question 10. Question number 1. Why should a magnesium ribbon be cleaned before burning in air? Question 2. Write the balanced equation for the following chemical reactions. First one, hydrogen plus chlorine is equal to hydrogen chloride. Second, barium chloride plus aluminium sulfate is equal to barium sulfate plus aluminium chloride. Third one, sodium plus water is equal to sodium hydroxide plus hydrogen. Question number 3. Write a balanced chemical equation with symbols for the following reactions. 1. Solution of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. Second, sodium hydroxide solution in water react with hydrochloric acid solution in water to produce sodium chloride solution and water. Thank you. Class 10th, Subject Science. Chemical reactions and equations. Page number 6. Exercise 1.2. Types of chemical reactions. We have learnt in class 9 that during a chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. You will study about types of bonds formed between atoms in chapter 3 and 4. 1.2.1 Combination reactions. Activity 1.4. Take a small amount of calcium oxide or quicklime in a beaker. 2. Slowly add water to this. 3. Touch the beaker as shown in figure 1.3. 4. Do you feel any change in temperature? In figure 1.2, formation of slacked lime by the reaction of calcium oxide with water is shown. Calcium oxide reacts vigorously with water to produce slacked lime, that is calcium hydroxide, releasing a large amount of heat. CaO plus H2O is equal to CaOH twice plus heat 1.13. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as combination reactions. Page number 7. A solution of slacked lime produced by the reaction 1.13 is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the wall. It is interesting to note that the chemical formula for marble is also CaCO3. CaOH2 calcium hydroxide plus CO2 is equal to CaCO3 plus H2O. 1.14. Let us discuss some more examples of combination reaction. First one, burning of coal. Calcium plus O2 is equal to CO2. 1.15. Second, formation of water from H2 and O2. Twice H2 plus O2 is equal to twice H2O. 1.16. In simple language, we can say that when two or more substances, elements or compounds combine to form a single product, the reactions are called combination reaction. In activity 1.4, we also observed that a large amount of heat is evolved. This makes the reaction mixture warm. Reaction in which heat is released along with the formation of product are called exothermic chemical reactions. Other examples of exothermic reactions are: first, burning of natural gas. CH4 plus twice O2 is equal to CO2 gas plus twice H2O gas. 1.17. Second, do you know that respiration is an exothermic process? We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes, and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is respiration, the process of which you will study in chapter 6. C6H12O6 plus 6O2 is equal to 6CO2 plus 6H2O plus energy. Third, the decomposition of vegetable matter into compost is also an example of an exothermic reaction. Identify the type of reaction taking place in activity 1.1, where heat is given out along with the formation of a single product. Now page number 8. Decomposition reaction. Activity 1.5. Take about 2 gram ferrous sulfate crystals in a dry boiling tube. Second, note the color of the ferrous sulfate crystals. Third, heat the boiling tube over the flame of a burner or spirit lamp as shown in figure 1.4. Fourth, observe the color of the crystals after heating. In figure 1.4, correct way of heating the boiling tube containing crystals of ferrous sulfate and of smelling the odor. Have you noticed that the green color of the ferrous sulfate crystal has changed? You can also smell the characteristic odor of burning sulfur. Twice FeSO4 on heating Fe2O3 plus SO2 plus SO3. This is equation 1.19. In this reaction, you can observe that a single reactant breaks down to give simpler product. This is decomposition reaction. Ferrous sulfate crystals FeSO4, 7H2O lose water when heated and the color of the crystal changes. It then decomposes to ferric oxide Fe2O3, sulfur dioxide SO2 and sulfur trioxide SO3. Ferric oxide is a solid while SO2 and SO3 are gases. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in manufacture of cement. When a decomposition reaction is carried out by heating, it is called decomposition. CaCO3 limestone on heating CaO quicklime plus CO2. This is equation 1.20. Another example of a thermal decomposition reaction is given in activity 1.6. Activity 1.6. 1. Take about 2 gram lead nitrate powder in a boiling tube. 2. Hold the boiling tube with a pair of tongue and heat it over a flame as shown in figure 1.5. 3. What do you observe? Note down the change if any. In figure 1.5, heating of lead nitrate and emission of nitrogen dioxide. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide NO2. The reaction that takes place is page number 9. Twice Pb NO3 twice on heating twice PbO lead oxide plus 4NO2 nitrogen dioxide plus O2 oxygen. This is equation 1.21. Let us perform some more decomposition reaction as given in activities 1.7 and 1.8. Activity 1.7. Take a plastic mug. Drill 2 holes at its base and fit rubber stopper in these holes. Insert carbon electrodes in these rubber stopper as shown in figure 1.6. Second, connect these electrodes to a 6-volt battery. Third, fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. 4. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. 5th, switch on the current and leave the apparatus undisturbed for some time. 8. You will observe the formation of bubble at both the electrodes. These bubbles displace water in the test tubes. 9. Is the volume of the gas collected the same in both the test tubes? 10. Once the test tubes are filled with the respective gases, remove them carefully. 12. Test these gases one by one by bringing a burning candle close to the mouth of the test tube. Question. This step must be performed carefully by the teacher. What happens in each case? Which gas is present in each test tube? In figure 1.6, electrolysis of water has shown. Activity 1.8. Take about 2 grams silver chloride in a china dish. What is its color? Place this china dish in sunlight for some time, as shown in figure 1.7. Observe the color of the silver chloride after some time. In figure 1.7, silver chloride turns grey in sunlight to form silver metal. You will see that white silver chloride turns grey in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. Twice AgCl on giving sunlight is equal to 2Ag plus Cl2. This is equation 1.22. Page number 10. Silver bromide also behaves in the same way. Twice AgBr on giving sunlight is equal to twice Ag plus Br2. This is equation 1.23. The above reactions are used in black and white photography. What form of energy is causing these decomposition reactions? We have seen that the decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. Reaction in which energy is absorbed are known as endothermic reactions. Carry out the following activity. Take about 2 gram barium hydroxide in a test tube, add 1 gram of ammonium chloride and mix with the help of a glass rod. Touch the bottom of the test tube with your palm. What do you feel? Is this an exothermic or endothermic reaction? Questions. A solution of substance X is used for whitewashing. 1. Name the substance X and write its formula. 2nd. Write the reaction of the substance X named in 1 above with water. Second question. Why is the amount of gas collected in one of the test tube in activity 1.7 double of the amount collected in the other? Name this gas. 1.2.3 Displacement reaction. Activity 1.9. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. After 20 minutes, take out the iron nail from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solution in test tube A and B. Figure 1.8. Also compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside. Figure 1.8. In figure 1.08, iron nails dipped in copper sulfate solution. Page number 11. In figure 1.8b, Iron nails and copper sulfate solution compared before and after the experiment. Why does the iron nail become brownish in color and the blue color of copper sulfate solution fades? The following chemical reaction takes place in this activity. Fe plus CuSO4 copper sulfate is equal to FeSO4 iron sulfate plus Cu. This is equation 1.24. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Other examples of displacement reactions are Zn plus CuSO4 copper sulfate is equal to ZnSO4 zinc sulfate plus Cu, equation 1.25. Pb plus CuSl2 copper chloride is equal to PbCl2 lead chloride plus Cu, equation 1.26. Zinc and lead are more reactive element than copper. They displace copper from its compounds. 1.2.4 Double displacement reaction. Activity 1.10. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the two solutions in figure 1.9. What do you observe? You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. Na2SO4 sodium sulfate plus BaCl2 barium chloride is equal to BaSO4 barium sulfate plus twice NaCl sodium chloride. This is equation 1.27. In figure 1.9, formation of barium sulfate and sodium chloride. Page number 12. What causes this? The white precipitate of BaSO4 is formed by the reaction of SO4 2- and Ba 2+. The other product formed is sodium chloride, which remains in the solution. Such reaction in which there is an exchange of ion between the reactant are called double displacement reactions. Recall activity 1.2, where you have mixed the solution of lead nitrate and potassium iodide. First one. What was the color of the precipitate formed? Can you name the compound precipitated? Second, write the balanced chemical equation for this reaction. Third, is this also a double displacement reaction? 1.2.5 Oxidation and reduction. Activity 1.11. Heat a china dish containing about 1 gram copper powder. Figure 1.10. What do you observe? In figure 1.10, oxidation of copper to copper oxide. The surface of copper powder becomes coated with black copper oxide. Why has this black substance formed? This is because oxygen is added to copper and copper oxide is formed. Twice Cu plus SO2 on heating is equal to twice CuO. This is equation 1.28. If hydrogen gas is passed over this heated material, CuO, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. CuO plus H2 on heating, Cu plus H2O, 1.29. If a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. During this reaction 1.29, the copper oxide is losing oxygen, and in other words, the hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized while the other gets reduced during a reaction. Such reactions are called oxidation reduction reactions or redox reactions. CuO plus H2 on heating is equal to Cu plus H2O. Equation 1.30. Some other examples of redox reactions are ZnCO plus C is equal to Zn plus CO 1.31. MnO2 plus 4HCl is equal to MnCl2 plus twice H2O plus Cl2. Equation 1.32. Page number 13. In reaction 1.31, carbon is oxidized to CO and ZnO is reduced to Zn. In reaction 1.32, HCl is oxidized to Cl2 whereas MnO2 is reduced to MnCl2. From the above example, we can say that if a substance gains oxygen or loses hydrogen during a reaction, it is oxidized. If a substance loses oxygen or gains hydrogen during a reaction, it is reduced. Recall activity 1.1, where a magnesium ribbon burns with a dazzling flame in air, oxygen, and changes into a white substance, magnesium oxide. Is magnesium being oxidized or reduced in this reaction? 1.3. Have you observed the effect of oxidation reaction in everyday life? 1.3.1. Corrosion. You must have observed that iron particles are shiny when new, but get coated with a reddish-brown powder when left for some time. This process is commonly known as rusting of iron. Some other metal also get tarnished in this manner. Have you noticed the color of coating formed on copper and silver? When a metal is attacked by substances around it, such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to all the objects made of metals, especially those of iron. Corrosion of iron is a serious problem. Every year, an enormous amount of money is spent to replace damaged iron. You will learn more about corrosion in Chapter 3. 1.3.2 Rancidity. Have you ever tasted or smelled the fat or oil containing food materials left for a long time? When fats and oil are oxidized, they become rancid and their smell and taste change. Usually substances which prevent oxidation, antioxidants, are added to food containing fats and oils. Keeping food in airtight containers help to slow down oxidation. Do you know that chip manufacturers usually flush bags of chips with gas, such as nitrogen, to prevent the chip from getting oxidized? Now questions. 1. Why does the color of copper sulfate solution change when an iron nail is dipped in it? Question 2. Give an example of a double displacement reaction other than the one given in activity 1.10. Question 3. Identify the substances that are oxidized and the substances that are reduced in the following reactions. 1. 4Na plus O2 twice Na2O. Second, CuO plus H2 Cu plus H2O. Page number 14. In this chapter, we are going to learn that what we have learned in chapter number 1, Chemical Reactions and Equations. What you have learned. Now the points. A complete chemical equation represents the reactants, products and their physical states symbolically. 2. A chemical reaction is balanced that the number of atoms of each type involved in a chemical reaction are the same on the reactant and product sides of the equation. Equation must always be balanced. Third, in a combination reaction, two or more substances combine to form a new single substance. 4. Decomposition reaction are opposite to combination reaction. In a decomposition reaction, a single substance decomposes to give two or more substances. 5. Reactions in which heat is given out along with the product are called exothermic reaction. 6. Reaction in which energy is absorbed are known as endothermic reaction. 7. When an element displaces another element from its compound, a displacement reaction occurs. 9. Two different atoms or group of atom ions are exchanged in double displacement reaction. 10. Precipitation reaction produce insoluble salts. 11. Reactions also involve the gain or loss of oxygen or hydrogen by substances. Oxidation is the gain of oxygen or loss of hydrogen. Reduction is the loss of oxygen or gain of hydrogen. Now exercises based on this chapter. Exercise 1. Which of the statements about the reaction below are incorrect? Twice PbO plus C is equal to twice Pb plus CO2. A. Lead is getting reduced. B. Carbon dioxide is getting oxidized. C. Carbon is getting oxidized. D. Lead oxide is getting reduced. Option 1. A and B. 2. A and C. 3. A, B and C. 4. All. Question 2. Fe2O3 plus twice Al is equal to Al2O3 plus twice Fe. The above reaction is an example of A. Combination reaction. B. Double displacement reaction. Page number 15. Option C. Decomposition reaction. Option D. Displacement reaction. Question number 3. What happens when dilute hydrochloric acid is added to iron filings? Take the correct answer. Option A. Hydrogen gas and iron chloride are produced. Option B. Chlorine gas and hydroxides are produced. C. No reaction take place. D. Iron salt and water are produced. Question 4. What is a balanced chemical equation? Why should chemical equation be balanced? Question 5. Translate the following statement into chemical equation and then balance them. A. Hydrogen gas combined with nitrogen to form ammonia. B. Hydrogen sulfide gas burns in air to give water and sulfur dioxide. C. Barium chloride react with aluminium sulfate to give aluminium chloride and a precipitate of barium sulfate. D. Potassium metal react with water to give potassium hydroxide and hydrogen gas. Question 6. Balance the following chemical equation. A. HNO3 plus CaOH2 is equal to CaNO3 2 plus H2O. B. NaOH plus H2SO4 Na2SO4 plus H2O. C. NaCl plus AgNO3 is equal to AgCl plus NaNO3. D. BaCl2 plus H2SO4 BaSO4 plus HCl. 7. Write the balanced chemical equation for the following reactions. Calcium hydroxide plus carbon dioxide is equal to calcium carbonate plus water. B. Zinc plus silver nitrate is equal to zinc nitrate plus silver. C. Aluminium plus copper chloride is equal to Aluminium chloride plus copper. D. Barium chloride plus potassium sulfate is equal to barium sulfate plus potassium chloride. Question 8. Write the balanced chemical equation for the following and identify the type of reaction in each case. A. Potassium bromide plus barium iodide is equal to potassium iodide plus barium bromide. B. Zinc carbonate is equal to zinc oxide plus carbon dioxide. C. Hydrogen plus chlorine is equal to hydrogen chloride. D. Magnesium plus hydrochloric acid is equal to magnesium chloride plus hydrogen. Question 9. What does one mean by exothermic and endothermic reactions? Give examples. Question 10. Why is respiration considered an exothermic reaction? Explain. Question 11. Why are decomposition reactions called the opposite of combination reactions? Write equation for these reactions. Now page number 16. Question 12. Write one equation each for decomposition reaction where energy is supplied in the form of heat, light or electricity. Question 13. What is the difference between displacement and double displacement reaction? Write equation for these reactions. Question 14. In the refining of silver, the recovery of silver from silver nitrate solution involved displacement by copper metal. Write down the reaction involved. Question 15. What do you mean by a precipitation reaction? Explain by giving examples. Question 16. Explain the following in terms of gain or loss of oxygen with two examples each. A. Oxidation. B. Reduction. Question 17. A shiny brown colored element acts on heating in air, becomes black in color. Name the element X and the black colored compound formed. Question 18. Why do we apply paint on iron particles? 19. Oil and fat containing food items are flushed with nitrogen. Why? Question 20. Explain the following terms with one example each. A. Corrosion. B. Rancidity. Now group activity. Perform the following activity. Take 4 beakers and label them as A, B, C and D. Put 25 ml of water in A, B and C beaker and copper sulfate solution in beaker D. Measure and record the temperature of each liquid contained in the beakers above. Add 2 spatulas of potassium sulfate, ammonium nitrate, anhydrous copper sulfate and fine iron fillings in beaker A, B, C and D respectively and stir. Finally, measure and record the temperature of each of the mixture above. Find out which reactions are exothermic and which ones are exothermic in nature. Thank you. Please study, please listen it carefully and attempt the exercises.